Okay, so for this particular counter, it uses an exclusive OR gate. And I wanted to remind ourselves of the truth table for an exclusive OR gate. So an exclusive OR is 1 when one of the two inputs is 1 but not both. So, and it's 0 otherwise. So 0 because there's no 1, 1 because there's a 1, 1 because there's a 1, and 0 because there are two 1s. If you have more than two inputs, an exclusive OR is 1 if you have an odd number of 1s. So if you had a whole bunch of things exclusive ORed together. Okay, so now we're going to draw the circuit for a 4-bit up counter with D flip-flops. Now this is in your book and probably in your notes as well, I'm not sure, but I thought it would be helpful to draw it just because if you draw it, it just kind of reminds you of what all the parts are, and so that can help you a little more figure out what's going on. So it's a 4-bit counter, so we have 4 flip-flops. It's a D, we're using D flip-flops. And we're not using the Q bar on this one, so I'm not going to draw it in just to save time. We do have a clock, but the clock doesn't affect anything. Well, it's important, so I mean, that's when things change, so I will draw it in. And our outputs will be labeled Q0, Q1, Q2, Q3. And each of these D flip-flops has an exclusive OR gate. That's the one that looks like this. So an OR gate with a little extra line on it. And the input to the D flip-flop is the output from that exclusive OR. We also have some AND gates. This last AND gate is not really going to come into our discussion. I'm just going to, those are lovely AND gates. Just going to draw it as an output Z because if you were going to connect different, like if you wanted to make an 8-bit up counter, you might do connect a 4-bit up counter with another 4-bit up counter. And into our first exclusive OR, we have the Q0, and we also have an enable. So nothing happens if the enable is 0. And so the Q0 and the enable are the inputs for the first exclusive OR, and the enable and this Q0 are the inputs for the first AND gate. This AND gate is now one of the inputs for this exclusive OR, and the other one is Q1, and that Q1 is also an input for the next AND gate. Okay, and the second input for this next AND gate is the output from the AND gate above it. Now the output from this AND gate is going to go to the next AND gate. It's also going to go to this exclusive OR, and like before, this is going to come back around and be an input into the exclusive OR, and it will be the other input into that AND gate. And then for Q3, we'll have the same thing. So Q3 is the input for the exclusive OR. The other input is the AND gate, and this Q3 is going to be the input for that. Okay, so we've drawn it. At this point, you're like, okay, that's a lot of stuff. Sure. Okay. But then the next thing I want to do is to write expressions for D0, D1, D2, and D3. So these are the expressions for what's going in to these D flip-flops. And so if we look at what's going in to this D flip-flop, it's Q0 exclusive OR 1. We're assuming the enable is 1. So that's it. D1 is Q1 exclusive OR Q0, because even though this is an AND, it's an AND of Q0 and 1, and the AND of anything with 1 is just itself. Now D2 is the exclusive OR of Q2, and let's see what we've got here. This was Q0, this was Q0 coming out, and then we're ANDing it with Q1. So this is Q0 and Q1. And then D3 is going to be Q3 exclusive OR, and then this AND is the AND of Q2 and Q0, Q1, So this is Q0, Q1, Q2. Okay, so let's now look at what our outputs are going to be. So I'm going to start with Q0. So when we start, these are all 0. So when we start, Q0 is 0. And if we look at D0, D0 is Q0, which is 0, exclusive OR 1. What is 0 exclusive OR 1? 1. Okay, now next time around, Q0 is 1. What's 1 exclusive OR 1? 0. Okay, now Q0 is 0 again. 0 exclusive OR 1. 1. And then what's going to happen next? 0. And then 1, 1, 2, 3, 4, 5, 6, 7, 8. Oops. Okay, so what's happening to this least significant bit? What's it doing? It's just alternating. 0, 1, 0, 1, 0, 1, 0, 1. Okay, so now let's look at what Q1 is going to do. So Q1 is going to be the exclusive OR of Q1 and Q0 from the line above. So exclusive OR of Q1 and Q0. So what is the exclusive OR of these two? 0. Okay, now it's going to be the exclusive OR of these two. The exclusive OR of 0 and 1. And then the exclusive OR of 0 and 1. And then the exclusive OR of 1 and 1. And then 0 and 0. And 0 and 1. And 1 and 0. Yeah. I think I wanted to get one more.
Wait, so it started at 0 because it was waiting on the last one, or like why did it start at 0?
Why did it start at 0?
Yeah.
Because it was the exclusive OR of 0 and 0.
Oh.
I actually think I want one more here. 0 and 0. Okay, so now let's look at Q2. So Q2 is going to be the exclusive OR of Q2 and Q0 and Q1. So it's going to be the exclusive OR of these ANDed together and that. So Q1 and Q0, what's that? 0. And so the exclusive OR of 0 and 0 is 0. Okay, so now the exclusive OR, the AND of 0 and 1 is 0, and the exclusive OR of 0 and 0 is 0. The AND of 1 and 0 is 0. Exclusive OR of 0 and 0 is 0. The AND, the AND of 1 and 1 is 1. The exclusive OR of 1 and 0 is 1. The AND of 0 and 1 is 0, and the exclusive OR of 0 and 1 is, the AND of 1 and 0 is, AND of 0 and 1 is 0. Exclusive OR of 0 and 1 is 1. AND of 1 and 0 is, exclusive OR of 0 and 1 is, AND of 1 and 1 is 1. Exclusive OR of 1 and 1 is 0. Okay, so now let's go to D3, which is going to be Q3 exclusive ORed with all three of these ANDed together. Now, all three of these ANDed together is going to be 0 until we get down to this line right here. Because in each of these lines above, there's at least one 0. And if you AND something with a 0, you get a 0. So all of these ANDed together will be 0. So in each case, we'll be looking at the exclusive OR of 0 with 0, which is 0. Till we get to this last line. And what's the AND of 1 and 1 and 1? 1. Exclusive OR of 1 with 0 is 1. Now, if you look here, what we have, this is a counter. We've got the binary numbers for 0, 1, 2, 3, 4, 5, 6, 7, and 8. Have y'all done binary numbers? Yeah, okay. So it does in fact work as a counter. And so let's talk a little bit about it. Okay, so if you look at the way the binary numbers work, is you don't want to change the higher digit until all the digits before it are 1. And so that's why we have these ANDs here. Because, so like if we look at 3, we have zeros in Q2 until we get to 3, and in 3 we've filled up Q1 and Q0. Those are both 1s. That's when we want to change Q2 to 1. So that's why we have these ANDs here, because we don't want to change the next significant digit until everything before it is a 1. And when everything before it is a 1, that's when we want to change our next digit to a 1. So, and then in line 7, you've got all 1s. You want to then change the Q3 to 1 at that time. So you're always anding together the significant bits, the least significant bits before the one that you're looking at. And you don't want to change it until that's 1. So. Otherwise, if they're not all 1, their and would be 0, and since you haven't complemented it from 0 to 1 yet, then the exclusive OR of 0 and 0 is 0 and it won't change. Okay, so are there questions on that?
I understand how it works, but like, how would we? Is there any way to know how to draw something like this out from the start? You just gotta try.
Well, I mean, I guess maybe some people could. I think you would not be expected to. I think you'd be given the circuit, and then you'd have to figure out what to do with it. So, I mean, I would not have figured this out. I mean, maybe I could now because I've done it a bunch of times, but yeah. So I think usually the questions I've seen with counters have been along the lines of, this is a counter. What does it do? You know, you figure out, you do like what we did, and you figure out, is it counting up, is it counting down, or is it doing something else entirely? So.
The question on our homework is about this, but it doesn't give us the counter. It just asks us questions about it. It's really all.
Oh, I think it's in your book, though.
Yeah.
So I think that's, I had looked up your homework. I don't have it. Oh, wait.